Welcome back after the lunch break. We have an exciting opportunity now to hear Dr. Michael Stonebraker, and I'll let him introduce himself. So, without further ado, Michael, the microphone is yours.
Thank you, Derek. Can you hear me okay?
Yes, yes,
Can
very well.
do you see my screen?
I do.
All right. Gotta love technology.
Yes.
So I'm Mike Stonebraker. I'm on the faculty at MIT. My main claim to fame is that I've started 10 venture capital backed startups. And my next claim to fame is that I won the Turing Award in 2014 for my work on various data management topics. And I'm here today to talk to you about data mastering and to tell you why it's hard and what you should do about it. So the summary of this talk is that data mastering is hard because you've got to do it at scale, you've got to do it at scale, you've got to do it at scale, and that introduces all kinds of complexities that I will talk about in a bit. And then the other thing that makes data mastering hard is what I'll call unforced errors, which are usually the result of a rookie trying to learn on the job. So anyway, so that will be the most of this talk. And so the agenda that we'll go through in the next hour is what is data mastering, what does it mean, and then what is data mastering at scale, and then why do traditional solutions fail at data mastering when you have to do it at scale. And then if the traditional solutions fail, well, then I must have a solution for what works. So we'll talk about that. And then I'll talk about unforced errors, advice from the trenches, and wrap up. So what is data mastering? Well, this is going to be review for everybody. Enterprises are full of data silos. Why are there all kinds of data silos in enterprises? Because the CEO empowers independent business units to go do stuff. So if you're an enterprise and you decide you want to form a new business to go sell igloos to the Eskimos, you hire Derek, say, as the person to run this business unit, and tell him to go off and make a business. He has to get results in zero time. So he doesn't have the liberty to think about this for a couple years. So he puts on his rocket shoes and he goes off and tries to make stuff happen. And the quickest way to make stuff happen is to take the data that he needs, create his own version of it, and put it in his own data silo. If he doesn't do this, then it takes forever, and business agility goes out the window. And what's more, all decisions effectively have to go through God, because if I have to synchronize my data with a bunch of other business units that don't report to me, then God has to get involved, and it takes forever. So enterprises are full of data silos because you want to empower independent business units. Also, if you buy a business unit from somebody else, chances are it comes with a data silo, and few enterprises are willing to stop and figure out how to integrate the new business unit's data with existing data, and so you just create another silo. So there are lots of silos in big enterprises, and enterprises are finding out there is huge business value in integrating these silos. So just for example, if you have a bunch of independent business units, each of whom has a supplier database, and you know if I'm one of this business units and I have a contract with Staples, and when my contract with Staples comes up for renewal, I'd like to figure out the terms and conditions that everybody else managed to obtain from Staples so that I can demand most favored nation status. So getting the best price across independent business units requires integrating supplier databases. And by the way, General Electric has about 75 of these, and they figure it's worth about $100 million a year to manage to get the best price. And the best price is not with popular suppliers like Staples, it's all in the long tail. So get the best price requires you to integrate suppliers. If I'm the Derek and I'm trying to sell igloos to the Eskimos, and I want to sell to Anchorage Contracting, the first thing I want to know is, does anybody else in my enterprise have a contract with Anchorage Consulting? So I want to be able to integrate customers across independent business units, which requires me to integrate customer databases. One of the interesting cases that Tamer is working on is with Carnival Cruise Lines. They're the guys who have the big white boats. It turns out Carnival is in fact 9 different cruise lines that have been purchased over time. So Carnival is one. It turns out Holland America is a second one, and there's 7 more. So they want to integrate spare parts between the various boats. And of course they have 9 different spare parts databases. And you know, some spare parts are on the boat, some are on the dock, some are in the warehouse. And if I don't have the right stuff, I want to see if I can get it from some other boat. So that requires Carnival to integrate 9 different parts databases. So silo integration has huge business value to getting it done. So what does this mean? It means after the fact, I need to integrate independently constructed data sets for common entities like parts and suppliers and customers. Now, if you don't learn anything else from this talk, at least tattoo the red stuff at the bottom of the slide on your brain. Independently constructed schemas are never, ever, ever plug compatible. I've never seen 2 independently constructed schemas that you can just merge. It just doesn't happen. Why doesn't it happen? If you want to do silo integration, first thing you have to do is move the data to a common place so you can operate on it. If you want to think of this as a data warehouse, that's fine. If you want to think of this as a data lake, that's fine. If you want to think of it as a lake house, the most recent terminology from Amazon, that's fine too. So get data sets to a common place, and then you're going to have to perform a bunch of transformations. So for example, if you're the human resources guy in Paris, I'm the human resources guy in New York. You have employees, I have employees. You have salaries, I have salaries. However, yours are in euros and include a lunch allowance and are after taxes. Mine are gross before taxes, no lunch allowance. So you've got to perform transformations to get data into common units and meaning. You've also got to line up the various schema elements. You call it wages, I call it salaries. You got to line up the various columns to mean the same thing. As a rule of thumb, you should assume that 10% of your data is dirty or missing. So one very simple case is that if you have numeric data, some people often, if the data was missing, they would stick in minus 99. What that really means is null. If you have two databases with two sets of salaries, one of them uses null and a bunch of positive numbers. The other one uses minus 99 to mean null and then a bunch of positive numbers. If you just ram those together, you will get garbage. So you've got to perform data cleaning, which means rationalizing nulls, and it means data that is dirty has to be cleaned up, or when you go to run analytics, you're going to get garbage out of your analytic systems. As often as not, you want to find extra attributes to help you in later steps of this process. That's called enrichment. So find some more joining attributes to make life easier later on. So for example, the Dow Jones classification for any given enterprise is often a useful thing to have on hand, and there are a bunch of others that may make sense. Then if I'm going to perform supplier integration, I've got to find everybody. I've got to find all the staples of the world in all these various databases and consolidate them together. So that's called entity consolidation. That requires finding all the records in the various databases that mean the same thing. Then, as often as not, I have a cluster of records that talks about staples, and so I want to have a single address of record for staples. I want to take the cluster, which has lots of different addresses, and I want to find a golden value for a column of this cluster so that I can have a preferred address. Then sometimes I want to perform classification on the result. I want to classify suppliers as international or local, and then it's inevitably true that this is not a one and done process, that all these databases get updated over time, and so I need to perform ongoing stewardship. So silo integration involves a pipeline of some number of the previous actions executed in some order. This is often called data mastering, often called master data management, often called data curation, data integration, data unification. All these words mean the same thing, and we will use the term data mastering to mean this integration of entities in silos. Okay, so that's what data mastering is all about, and most of you on this call have, your enterprises need to do this. So in this talk, we'll worry about three components of the pipeline, not because the others aren't important, it's just I can't talk about everything. So we'll talk about schema integration. Your wages are the same as my salary. We'll talk about entity consolidation, finding all the different records that correspond to staples, and classification, classifying staples as international or domestic. So that's what we're all about in this talk. Okay, what does it mean to do this at scale? It means hundreds or even thousands of entities, millions of records, often in hundreds to thousands of data sets, and inevitably with ongoing stewardship. So do this at scale, meaning your enterprise has a lot of data. Let me just give you a couple examples of what it means when I think of scale, what that means. So GlaxoSmithKline, GSK, is one of the big pharmas. They have all kinds of silos. They're initially focused on clinical trial data, which they do a lot of and which is in the news recently with COVID. However, they aspire to mastering research data worldwide. What does that mean? They have about order 10,000 research scientists, biologists and chemists sitting at lab benches doing wet stuff and writing down results of their experiments in what you can think of as electronic lab notebooks. So they aspire to mastering 10,000-ish research notebooks, and they want to facilitate scientists interacting with each other. Because if you're a scientist in Basel and you're producing a particular GOOK, I'm a scientist in Cambridge, I'm producing the same GOOK using a different technique. You want to be able to have us communicate with each other to see if we can share techniques. So if we have scientists producing the same GOOK or using the same reagents to produce different stuff, you want to facilitate interactions among a worldwide scientist community numbering 10,000-ish. There are many, many, many tables. Too many to actually count. And GSK has estimated they have more than 10 million column names. So do this at scale, hundreds of thousands of tables, millions and billions of column names. So do schema integration at that scale. Who does entity consolidation at scale? Well, Toyota Motor Europe is another Tamer customer. They aspire to mastering customers across all of Europe. Why do they want to do that? Well, if you buy a Toyota in Spain and then you get relocated to France, well, you drive your Toyota across the border, and to get service you then take it to the Toyota dealer in Lyon or wherever in France you are. Well, Toyota distributes in Europe on a country-by-country basis. So the Spain guys are different than the France guys, and they're both islands of information. They're both silos. So when you go to France, the French Toyota folks have amnesia. They know nothing about you. So in order to avoid customer amnesia, Toyota Europe wants to master customers across all of Europe. That's 30 plus million customers in approximately 250 databases. Most of these databases do not belong to Toyota. They belong to dealers and service centers which are not under the control of Intergalactic Toyota. And by the way, it's in 40 languages. So master customers, 30-ish million of them in 250 databases in 40 languages. So that's what they mean by data mastering at scale. My last example, which we'll use in a few minutes as an example, is a media company whose name I can't tell you. They want to master titles of content. Think of this as The Enterprise Strikes Back is also called Star Wars Episode 6, also called Star Wars Trilogy Version 6. There are a bunch of other names, all of which mean the same piece of content. So they want to be able to deduplicate the multiple names for the same thing to understand what content is being consumed and for legal royalty reasons. They have approximately, they have about 7.8 million records, and the duplicates are about a factor of 6. So this consolidates into about 1.5 million golden records. So that's what they mean by entity consolidation at scale. Oops, I lied. I have one more example. General Electric. General Electric has classified spend transactions worldwide, so the CFO can understand where the money goes. So for the time period that they were working with Tamer, they had about 20 million spend transactions. So they want to classify spend transactions into a pre-existing classification hierarchy, but there's 20 million of them to classify. So that's what they mean by classification at scale. Okay, so why don't traditional solutions scale? And when I say traditional solutions, I mean things like IBM, things like Informatica, things like Talent. So why don't the traditional elephant vendors scale to these kind of numbers? Well, if you look at schema integration, essentially all of the traditional vendors have a GUI, and you put table 1 on the left hand side and you put table 2 on the right hand side, and you have a human draw lines between salary and wages and anything else that happens to match. So that's a human powered solution. You think about this for about a millisecond, that is not going to scale to GSK's 10 million-ish attributes. This poor human will get carpal tunnel syndrome for sure, and it will take absolutely forever. So a manual process simply will work great if you have 10 tables, each with 10 attributes, but at scale, meaning millions of attributes, this is a non-starter. So you can't have a human-powered solution and have it scale. Okay, so what about entity consolidation? Well, again, what do the traditional elephants have to say about entity consolidation? Well, they call it match merge. So that's the piece of their systems that do entity consolidation. So what they view it as is that first you have to match all the records that are the same entity. They call that the match problem. That gives you a cluster of things that are all staples. And then you've got to merge the staple records into a golden record. They call that the merge problem. So the traditional solution is to do match merge. All of the major vendors say use a rule system to do this. So what does that mean? Well, if the edit distance between names of content is less than XXX, in this particular media company's example, then they're the same title. So that would be one rule, which is to say if lexicographically the titles are close, then they're probably the same thing. In terms of the merging problem, if you have a bunch of addresses for staples, well, take the most frequent one when you're merging things together. Another rule. So use a rule system to do match merge. Okay, so why doesn't that work? Well, I told you about the media company for a reason. They did exactly what the traditional vendors suggest, which is they didn't use one of the traditional vendors' products. They actually wrote a homebrew system, and they used rules to do a match and merge. They wrote 200,000 rules in this homebrew system. They've had 2 people working on this for 13 straight years. So over 13 calendar years, they have spent more or less $5 million, and they have 200,000 rules. they are in a quagmire. It takes forever to add a new data source because you have to wander into a 200,000 rule base and change it. And 200,000 rules is truly enormous. So changing anything takes forever. Takes forever to add a new data source. They are hauling around a big load of cinder blocks with thousands and thousands and thousands of rules. Why do they have to have so many rules? Well, here's an example in the user interface for Tamer, which has a GUI where you can look at clusters that Tamer thinks mean the same thing. This turns out to be for a company called B&G Foods. I have no idea what they do, but notice that there are 5 different data sets, and B&G is different. The name is different in every single one of them. The address is different in every single one of them. The city is, if you ignore capitalization, is 2 of them are the same, the rest are different. And of course, the state is, well, it's again kind of different. And the postal code is also kind of different. So just imagine a rule system to rationalize these 5 records. You can say, well, I can drop INC off the end of anything and then try and match it. I can take out the comma. I can remove the capitalizations. I can remove the ampersand. And I can remove incorporated as say that that's the same as INC and suppress that. So it takes a bunch of rules just to rationalize the various names for B&G Foods. And same thing is true of the other fields in this data set. Now here's another record, another cluster for a different company that's in the same application. So this is just a different cluster in the same data set. So this is for Deutsche Bank Capital Funding Trust, the 8, at number 8. So you look through this and you say, oops, you know, I've got the same problem. Capital and cap, the names, 3 of the 5 names actually are the same, but 2 of them are different. Addresses are all different, and so forth. So the way I have to write rules for Deutsche Bank is going to be different than for B&G Foods. So you can just start to realize that you're going to have to write a lot of rules. Okay. And so this media company has written 200,000 of them. Here's my final example. This has to do with classification. And of course, the traditional vendors, the elephants, say use a rule system. So, for example, classify any transaction from the company Staples as office supplies. 20 million of these transactions to classify. Write a rule that says Staples is office supplies. Now, the general rule, general wisdom, is that if I'm a single person, I can grok about 500 rules. So I can get my brain around about 500. Twist my arm and I will give you 2,000. I won't give you 20,000, and I certainly will not give you 200,000. Otherwise, there's exponential cost in grokking additional rules. So the problem is you need a lot of rules, and there's exponential cost in understanding them. So what did GE do? They wrote 500 rules in a rule notation, and they said, okay, how did that do on my 20 million transactions? it classified 10% of them. So they tried the traditional solution and it did 10% of the problem. So what are they going to do for the other 90%? 10% is not very interesting. They realized at that point it would be really daunting for them to try and write 5,000 plus rules to solve the entire problem using the elephant's traditional solution. So again, they're running into the same scale problem. So at scale, rule systems just don't work, and if you've got a lot of data, you've got a scale problem. So what to do instead? What do you have to do at scale? The answer is the only game in town that I know of that can scale is machine learning. So what is machine learning all about? Well, assume you have a task at hand. Say classify GE's 20 million records into this classification hierarchy that they have at hand. And so the desired outcome is for every one of their 20 million records, you want a classification bucket. And so just all you have to do is that. Okay, so using machine learning entails getting some training data. The training data is simply a collection of records and the classification bucket to which they belong. So it's some examples of the output that you're looking for. You then use this training data to fit a machine learning model, and the model then predicts the desired value for the rest of the data. And usually you use this with what's called active learning, which is once you classify everything using an ML model, you look at a sample of output records, and if you see ones that you know are wrong, fix the mistakes. And when you fix a mistake, that becomes the correct classification for a record, and you simply add that to the training data, run the model again. So that's what machine learning is all about. Get some training data and use the training data to fit an ML model. So training data is a huge problem, and I would be remiss if I didn't talk about it. At scale, this cannot be generated manually. If you have a human looking at every record in a large data set, chances are that's going to take a long time. And chances are, if you're trying to generate the correct financial classification for a given spend record, you can't delegate this to an unskilled person. So you can't just have Aunt Maud from Cedar Rapids, Iowa on Mechanical Turk doing this for you. So you have to have skilled personnel, and they're expensive and busy. So training data is often difficult to come by. Some enterprises have training data lying around from some previous effort. If you've got some training data, God bless you, you were lucky. If you don't, you need to construct some training data. I am not opposed to constructing training data using rules. So classify staples as office supplies, write 500 of those rules, but you're not going to use that to classify the data. You're going to use that as training data to fit an ML model, and then the ML model will classify the rest. So you only need to tag a small subset of the data, not all of it. And of course, if you're generating training data, not manually, then you've got to look at a sample of the training data and correct errors, just like we talked about a few minutes ago. Okay, so GE used the 2 million records from their 500 rules as training data to fit an ML model which classified the remaining 18 million records. It worked like a charm. So at scale, you've got to use machine learning. That's the only thing I know of that can scale to the kind of numbers that we're talking about. Rule systems do not scale. Any human line drawing system does not scale. Okay, so that's the first part of my talk. At scale, you've got to use machine learning. Nothing else that I know of will work. So if you've decided to use machine learning, there are still some challenges ahead of you. So I'm going to talk about a few of them in the remaining time that I have. The first thing that Tamer hears a bunch is, this doesn't look all that hard. Why don't I just get my favorite Python machine learning package, for example scikit-learn, and just start doing this myself. So if I'm a rookie, this is a standard thing. I'll learn on the job and I'll just run scikit-learn. The trouble is, machine learning is not trivial for the uninitiated. The first thing you've got to worry about is skew in the training data. If your training data is skewed, then your model will be crap. And when I say skewed, if you train a face recognition system on white people, it won't work for people of other skins. So skew in the training data has to be worried about. And then there's always errors in training data, always. So you have to worry about errors in training data. And then if you're going to do this for millions of records, you've got to have a scalable architecture. So you've got to be doing ML multi-core, multi-node, and that is not scikit-learn. So if you choose to use scikit-learn, then chances are you'll have to use something else when it comes around to having to do this at scale. And then you've got to overcome the rookie mistakes. Also, never forget that ongoing stewardship is a big challenge. So the first problem is that at scale, you're going to have a bunch of different experts. So you've got experts who are going to be checking your ML, telling you that you classified stuff wrong or that you've got the clusters wrong. The experts don't necessarily agree. Tamer's experience is they don't. And so you've got to worry about disagreement in stewardship, in the experts dealing with stewardship. Also, you run the model for a while, and there is model drift, which is over time things change a little bit. And you might change the categories, and your data kind of changes as your business kind of evolves. And at some point, you've got to go back and do the whole process all over again as models and categories change. Inevitably, you are going to have business users with different needs, and you're just going to have to deal with that. You're going to have to deal with model errors. The models that you run inevitably will have errors. You're going to have have an expert look at them and correct them. Otherwise, you're going to have garbage in, garbage out. And then, of course, it's never one and done. You've got new data sources, updates to existing data sources. So all of this is a challenge that you've got to worry about. So ML at scale is a challenge, and putting a rookie on it is not such a great idea. The other thing that's important is that at scale, algo makes a big difference. Algo means how you're actually doing the classification or the entity classification. These are n-squared problems, and scalable systems don't run n squared. They have ways to figure out how to do it cheaper, but algo is important. So let me just tell you a quick example. If you're doing schema integration like GlaxoSmithKline is doing, well, the direct way to do that is to build up a training set of pairs of matching attributes. Your salary is my wages, and construct a training data in that fashion. And you can't do this manually at scale. Use some rules or some other means, or you have some data lying around. So you build up a training set, and then you run an ML model to fit the remainder of the data. So that's what I've proposed so far, is just do ML directly on the problem at hand. However, there's another way to do it. So one thing GSK has is a lot of clinical trial data, and that kind of looks a little bit different than other kinds of research data. So a second way you could do this is to view schema integration as a classification problem, i.e. classify tables into like buckets. So if you just classify the tables into a collection of buckets, and then on each bucket run traditional ML. So that would simply a second algorithmic way to do the same problem. And at scale, it deserves careful thought to decide which way you're going to do this, which way is going to work out better. So algo is important, and of course parallelism and a multi-core, multi-node solution is crucial. Okay, so here's just a few pieces of advice that I have from observing a couple hundred projects that Tamer has done at scale. First of all, for goodness sakes, start small. Do not try and boil the ocean out of the starting gate. So for example, GE had 75 supplier databases. They didn't try and integrate all 75 in one swell foop. They integrated 2. And when that worked out okay, they added a 3rd. So start small, because if you don't start small, chances are you'll fail. And if you fail, your project will get canceled, and then you're done. And for goodness sakes, choose a good problem to start with. What that means is the one with the best chance at getting clean data. Because if the problem you choose has horribly dirty data, you will get mired down in trying to clean it, and you won't get any output, and you're being hired to produce better analytics, and you will again get canceled. And if you just run your analytics on dirty data, it will be garbage in, garbage out, and that will do you no good at all. Now, lots of Tamer customers don't have sophisticated in-house talent, and so they hire Tamer to help them get going, avoid the rookie mistakes, and so get experienced help if you don't have it in-house, and that way you will get going on the right track, and then you'll come up to speed, and then you can take over and do it yourself. So start small on a problem with the best chance at producing results that will mean something, and get experienced help if you don't have it in-house. And of course, my advice to everybody is if you don't have sufficient talent in-house, for goodness sakes, try and hire a couple of rocket scientists. And I know that's really, really difficult. Google and Facebook and Amazon seem to get first dibs on the people with PhDs in ML, but do the best you can. Try and get some sophisticated talent so that you have some in-house expertise. So what have I told you so far? Data mastering at small scale, hundreds of records, hundreds of tables, tens of tables, is not very difficult. Use anything, even your wristwatch. If you never have to scale, do it however you want. And the trouble is, at scale, you have got to use ML, and it's going to be an engineering challenge, probably, as I've talked about so far. So data mastering at large scale has to be done using ML, is often an engineering challenge. If large scale is in your future, meaning your Toyota Motor Europe or your GSK, get started on the right foot. Start going on an ML solution at the beginning. Otherwise, you're going to have to change the minute you figure out that your small scale solution doesn't scale. And when you choose a solution provider, if your chosen solution provider, and chances are you have one right now, one of the traditional vendors, if your chosen solution provider that is in-house right now does not use ML for schema integration, for deduplication, and for classification, and by the way, that's everybody, all the traditional vendors, then come see one of the newbies. So come see Tamer or somebody else who's going to use ML for these particular problems. Okay, I believe that's done. If you want to know more about Tamer, go visit their website, go schedule a demo, talk to one of their system engineers to see Tamer in action. That's the end of my slides. Thank you very much. I have 10 minutes till the top of the hour. I hope I've made somebody mad by now and that you'll ask some questions.
Dr. Stonebraker, Michael, thank you. That was really interesting, and enjoyed the subtle humor. There are two questions in the chat, and I'll just take them one after the other and just introduce them to you and get your thoughts. The one is talking about ROI, that return on investment thing. Now, obviously, one of the key things, and I'll kind of add a little bit of my interpretation of the question as well, based on what you've covered. Obviously, one of the key things that anyone who's in data and analytics leadership has to do is to, justify the costs of what they're trying to do up front and get funding to do stuff. And obviously, one of the areas that historically people have really struggled on is the traditional kind of approach to master data management, because you've got these massive solutions, very costly, and it takes forever to get anything out of it. To get your first real piece of value.
So Derek, you could give my talk.
There you go. So then when you start moving into more of the kind of the modern approaches and using machine learning, etc., the whole complexion of everything does change. Now, if you are in a company that has been trying to do master data management using a traditional approach, a new approach, a modern approach using ML is a breath of fresh air, and it's usually fairly easy to justify and to get people to buy in. But if you are a newbie to the whole data and analytics space, and no one's ever come up with an idea of doing master data management, this is your first ever situation in that organization, um, to embark on that. How do you go about, how have you seen people going about doing justifications? Or have most of your scenarios been in large organizations where they've been trying to do it in the past, have failed miserably, and then you guys can walk in with a new approach?
Mostly, most of Tamer's customers are Fortune 2000s
Right.
who have been trying to do this for years. And in general, we are approached by the business folks who say,
Okay.
there is an ROI here, just not using the traditional tools. Those have failed, and then we tell them to start small, which
Mm-hmm.
is do two data sources, figure out how much it costs, run your analytics, and prove that in fact there is going to be value here. Because I think start small on a small project where you can demonstrate value. Because unless you can demonstrate value, this looks like a sink for effort.
Yes. Right. Right. It's a
And so
black
just
hole.
just just for just for example, uh, one Tamer customer wanted to know how many suppliers do I have,
Mhm.
and so he oops, I'm sorry. You guys tell me to turn my phone off, and I didn't. Sorry. So he said, how many? The CEO said, how many suppliers do I
So,
have?
yeah.
And so Tamer did a small project and said, well, we can give you a better answer by doing more, but you are overcounting suppliers by about a factor of two. And that would change the entire way he looked at his business. And
Right.
so there are these sea changes
Mm.
that are the results that that are attainable. Uh, but you've got to demonstrate value on a small project up front. If you choose badly, then you're toast.
Yeah.
Because then you will fail, and management will say, well, yet
Yeah.
more failures.
Right. Right.
But I say
Okay.
you can talk to the Tamer guys. They are pretty good at helping you navigate the ROI landscape.
Right. Yeah, and I think you hit on it. In terms of the starting small and getting the buy-in, getting people to see where this is going, and then everyone starts jumping in after that. So, the second question, there are many different parts to it, but in essence, if I boil it down to what they're really getting at here, it sort of touches on a point that you were making, in that at some point you have to reach out to people in the data stewardship world to get them to weigh in, because if you go out to business folks in the organization and you start asking them for um, what does this mean and what are these rules about, etc., you get so many different opinions. And the question that this person poses is, does data suffer from problems related to the commons? Uh, the tragedy of the commons, basically, where everyone owns it, but no one owns it explicitly, and no one can speak authoritatively from a business perspective. So, in essence, what this person's intimating is that there's a need, if you're going to embark on mastering data, in parallel, you've got to embark on getting data governance in place, so that you've got that ability to reach out to an owner of that data to get an authoritative yes or no, on something that needs to happen to make things go forward.
So if mastering projects don't come from the top,
Yeah.
then you're not going to get the buy-in of
Right.
all these various stewards. And because if like in the case of 10,000 lab scientists, the only common ancestor that they have in the GSK hierarchy is the CEO.
Right.
And so it's got to come from the top,
Yeah.
because otherwise every single business unit will say, I'm too busy, go
Right.
away.
Right.
And so you need their buy-in, and if you can't get that, if you don't have the support of top management, you're working for the wrong company.
Yeah. Yeah. Makes
Because nothing is ever going to work. I mean, your analytics aren't going to work without clean data. And if you can't get clean integrated data, if there's no way to do that, then you're going to produce garbage that's not going to be very helpful to the enterprise. So my advice to you is quit and go work for somebody. And I think one reasonable test that I thought was really interesting was the chief data officer of GSK said, when I took this job, uh, I demanded read access to every single piece of enterprise data that GSK has. And the CEO said, no way, I can't do that. And this particular person said, well, I'm out of here, unless I can at least figure out, what I've got. I can't get anywhere. And so I think the answer is, there's a few simple questions you can ask that can tell you whether you have a good chance of succeeding or not.
right. Right. And I suppose along with that is, you know, determining upfront what the measures of success are going to be. Um,
Absolutely.
yeah.
I mean, that's isn't that business administration 101 or
101.
something?
Yeah, that's right. But it's funny how so often when we get into the thick of things, we forget some of those things, and then we go, oh, what was I thinking? Anyway, we could, I'm sure, go on for quite some time. I know you when you started off this talk, you said, here's my agenda, and there's only a few things I'm going to talk about because I can't talk about everything else in the time allotted. I know that if we had more time, we could go for a long time on this particular topic. But thank you very much for condensing it down and putting it into a nutshell for us. Very insightful. And we are running up against the end. So just again, thank you for your insights, and to the rest of the folks on the line watching this, I'm sure you've enjoyed it, and this has been recorded, so it is going to be available. I'm sure more people will watch it because the multiple streams of folks, and I'm sure a number who are in some of those other streams also want to see this. So there'll be more dialogue as we go forward, I'm sure.
Sounds great. Well,
All right.
thank you, Derek, and I had a great time giving the talk.
Excellent.
Okay,
Thanks.
take care.
Take care.